Good evening guys, Bagus to Mark C from BSME4. So here is my answer for number 1. So the givens from number 1 are T1 which is equal to 20 degrees Celsius. So you have to make it into a standard form. So you have to add 273 to make it 293 Kelvin. And the P1 is equal to 1.01 bar, and the RC is equal to 18 there. So first we have to find the value of the PVT. So first one is getting the value of T2. So by using this formula we get the value of T2. T2 over T1 is equal to V1 over V2 raised to K minus 1, but V1 over V2 is equal to RC. So we can derive this formula into T2 over T1 is equal to RC raised to K minus 1. So from this formula, T2 is equal to T1 RC K minus 1. So T2 is equal to, we have to substitute all the data here. T1 which is equal to 293 Kelvin multiplied by RC which is 18 raised to K, because it's air. The standard for K is 1.4 minus 1. So T2 is equal to 293 times 18 raised to 1.4 minus 1. T2 is equal to 931.058 Kelvin. So the next one is finding the pressure 2. So pressure 2 over pressure 1 is equal to V1 over V2 raised to K. So this is also equal to RK raised to K. So we can use this formula. P2 is equal to P1 RK raised to K. RC. So from this you will have to substitute all the data here. P1 which is 1.01 bar, and RC 18 raised to RC raised to K which is 1.4. We will get a value of so the value is 57.77 bar. That's the P2. So next one is finding the temperature 3. So here's the back. P3 over P2 is equal to T3 over T2. Since P3 V3 over T3 is equal to P2 V2 over T2, and the V3 is equal to V2, we will use this formula. T3 is equal to P3 over P2 times T2. So from this formula we will get P3 which is 69 bar times the T2 which is 931.058 over P2 over 57. The P2 is equal to 57.77. So the T3 that we will get from this equation is equal to 69 times 931.058 over 57.77. It's equal to 1112.0478 Kelvin. So now the heat added at constant volume is equal to the heat added at constant pressure in this problem. Therefore, we will use this formula. CV T3 minus T2 is equal to CP T4 minus T3. So the CV for standard air is equal to 0.718 multiplied by the T3, which is 1112.0478 minus the T2, which is 931.058 is equal to the CP of standard air is equal to 1.005, and T4, which what we are looking for, minus T3 is equal to 112.0478. So T4 that we get from here is equal to 0.718 times 1.0478 minus 931.058 is equal to 1.005 times the T4 minus 1112.0478 is equal to 1241.352 Kelvin to find the value of V5 over V4. So by using this equation, P3 V3 over T3 is equal to P4 V4 over T4. So V4 over V3 is equal to T4 over T3 is also equal to 1241.352 Kelvin. T3, which is equal to 1112.0478 Kelvin. So the answer that we will get from here is 12.352 over 1112.0478 is equal to 1.116. So from this, V5 is equal to V5 over V4 is equal to V1 over V4 is also equal to V1 V3 over V2 V4. So we can V1, since V1 and V2 is equal to RC 18 times 1 over 1.116. So V5 over V4, we can get the value of it equal to 16.129 there. So now we can solve the value of T5 by using this formula. T4 over T5 is equal to V5 over V4 raised to K minus 1. So V5 over V4 is equal to 16.129 raised to 1.4 minus 1 is equal to 3.041, and substituting this from here, we get T5 is equal to T4 over 3.041. So T4 is equal to 1241.352 Kelvin over 3.041. So T5 is equal to 408. T5 is equal to 408.205. So that's the T5. Then now the heat supplied, Q1 is equal to CV T3 minus T2 plus CP T4 minus T3. So for the Q1, 0.718 times the T3, 1112.0478 minus T2, which is 931.058 plus CP, which is 1.005 multiplied by the T4, which is 1241. T4 is equal to 1241.352 minus T3, which is equal to 1112.0478. So Q1 is equal to times 112.0478 minus 931.058 plus 1.005 times 1241.352 minus 1112.0478. It's equal to 259.901 kilojoule per kilogram. So that the heat rejected Q2 is given by this formula. Q2 is equal to CV by substituting the temperature that we got earlier, T5 minus T1, which is 0.718 times the T5 here, 408.205 minus the T1, which is equal to 293. So 0.718 times 408.205 minus 293 is equal to 82.717 kilojoule per kilogram. So that's the Q2. So now we can finally solve the thermal efficiency for the dual combined cycle. So the formula for efficiency is equal to 1 minus Q2 over Q1. So 1 minus Q2, which is equal to 82.717 over Q1, which is equal to 259.901. Now we can solve the efficiency. 82.717 over 259 is equal to 68.70, 0.6817. So you can multiply this by 100% to make it a percentage. So the final answer is 68.17%. So the thermal efficiency for the dual combined cycle is 68.17%. Thank you.